Hello and welcome back to my RC channel. I'm Andy RC, and today I'm doing an update video on my Scisky build. If this is the first time you have seen this aircraft on the channel, then I encourage you to go and watch the original build video because not much has changed, and also the video where I had the flyaway. I will link those below. The aircraft is back. It's not the same one, unfortunately. As you may have seen in my previous video, the first version flew off, never to be seen. I really like the build though, and I also wanted to get to the bottom of why it flew off. Thanks to Lee from Painless 360 for reprinting me this frame. I have also been sent this new race band micro VTX from FPV Hobby. It's identical to their previous 5.8 GHz VTX, only this time there is 8 race band channels, so you will need to use the Next Wave video receiver or one that supports the race band frequencies. It's red in colour, but the components and wiring are the same as the previous one. FPV Hobby has also sent me their new crash-proof micro Cloverleaf antenna with it. With their previous antenna, in a hard crash the Cloverleaf could come apart. I've only had this happen once to me mind. On this version there is a big blob of solder to stop that from happening. One thing I forgot to mention in the first build video is that the VTX has a potentiometer on it which allows you to alter the power output from around 10 milliwatts to 100 milliwatts. Just place a screwdriver in it and turn it carefully. Now I have rebuilt it, I can show you what I changed in order to get rid of the noise on the video. Previously, I used a micro JST cable connected direct to the onboard regulator of the Scisky. As shown in the first video, this created some noise on the video itself. It wasn't bad, but I wanted to rectify it. To achieve that, I used one of FPV Hobby's 5-volt regulators and connected it direct to the battery connector of the Scisky. This then feeds the regulated power to the VTX and camera rather than from the built-in regulator on the Scisky. Something else that I have changed up is the placement of the VTX on the board. There was definitely some noise being filtered through to the VTX by having it in close proximity to the flight controller. On this 3D printed frame, the VTX slots in perfect at the front. I used hot glue around the edges to secure it in. I wouldn't usually use hot glue on a VTX as the heat that comes from it can melt the hot glue. However, if you just glue around the edges of this VTX, then there's no heat coming from that part of it to melt anything. I forgot to mention in the first build video that I am using these cool micro battery straps from picnicquads.com. I cut them a bit shorter and they work perfect to hold the battery in. There's even a cutout in the frame that makes them fit perfect. The Velcro is really thin, so they are nice and tidy but very effective. If you saw the video where my first build flew off, I blamed either the Scisky board or the Devo 7E transmitter. So for this build, I'm going to use my Taranis transmitter coupled with an Orange RX module to see if I experience the same issue. Something else that I planned to address before the first version flew away was the flight modes. In the first video I only set up 2 flight modes, but there are actually 3 main ones. They are Acro, which has no stability at all, Angle mode, which is the auto level mode, and Horizon, which is a hybrid of the two, allowing you to do flips but the quadcopter will level itself out. The board without any switches set up is in Acro mode as standard, so I can set up a 3-position switch on my Taranis transmitter to have Acro, Angle and Horizon, and set it up in clean flight as shown here. When the first version flew off, a lot of people asked me about the Failsafe. The Failsafe was working correctly and I can show that again before I take it for a flight. All I have to do is set the Failsafe settings on the Taranis to no pulses. Then I need to have a look in clean flight where the bottom PWM value lies on my throttle when it is at idle, and then drop the failsafe value to lower than that. Then, when I turn my transmitter off while the motors are running, the motor should stop when the failsafe kicks in. It shouldn't level out like it did in the video, freeze and then climb, which is what it did to me with the flyaway. Interestingly though, other subscribers have had a similar issue with their Scisky board, all of them involving the Devo transmitter though. So let's go and take it for a fly and see if I have better luck this time. As this was a second attempt at building this quad, and the fact that I didn't film it meant that it was a much cleaner build. There's one thing harder than micro soldering, and that is trying to film micro soldering. You will notice that I'm not flying far away from myself. It's a bit daft really, as I don't suspect distance was the cause of the flyaway. As long as there is a positive throttle when the signal is lost, it doesn't matter how far away you fly, the thing will fly away on its own. I suppose this time I know that if I turn the TX off, it should fall out of the sky. I'm sure the more I fly it, the more confident I will become in pushing it further, but for now I think I'm going to stick to flying this one indoors. I have so much fun indoors with this quad, and you can fly it just like a 250 size quad, but inside. As you can see from this footage, it also pulls it off outside too. I need to do some work on the PIDs. You can see that when it falls out of a roll, I get a bobbing effect as the quad tries to recompose itself. This is usually a sign of not enough D value, so I will have to mess around with that. I have to say though that for indoor use the Lux float setting is perfect. The imperfections in the setup are definitely how it is reacting to the wind. It's gusting about 8 to 15 mile an hour wind today, and gusting is the worst kind when trying to get a smooth result out of a flight controller. Usually what happens when I build a quad like this is I fly it around quite gingerly for a while, and then when I feel I have had my money's worth out of it, I loosen the chains a little and take more risks. As this is the second one I have built, I think it may take a few flights before I feel like I have gotten my money's worth out of it. But fear not, because this aircraft flying away actually helped me to make the decision on building a 250 size race quad, which I plan to document on the channel. For the moment, these little brushed controller boards are mostly using DSM-2 for control. I do stress the phrase for the moment though, because I understand that there are other options. Using the multi-flight board in conjunction with the DSM-X satellite, for example. What I really like about the Scisky though is its singular design where everything is built in, and I'm sure that we will get one of these little controllers with perhaps a built-in FreeSky compatibility or something of the sort. I did plan on building a brushless micro quad, and I don't completely rule that out, but when I weigh up a couple of factors, it makes more sense to build a 250 size quad. I originally built micros to fly inside in the winter. In whichever way you look at it, a brushless micro would be too fast and dangerous to fly inside. So rather than limit myself to the components that would fit on a brushless micro quadcopter, I'm building the 250. So watch out for that on the channel. It's still in very early stages, so it may be a few weeks before you start to see videos coming out. So there you go, that is my second build with the Scisky controller board. Look out for more videos. I might do one where I tune the PIDs, and who knows, maybe I get brave enough to fly it properly outside again. I hope you enjoyed the video. Thanks so much for watching. Please continue to subscribe. Cheers.